a network is just an interconnection. Okay, a network is an interconnection of two or more devices exchanging information or resources. Okay, and the resources here that I'm talking about, it could be a PDF file. Okay, it could be a PDF file, an image, okay, a song, okay, it could be what, video, okay, and so on. Okay, so those are the kind of resources that we can share when we are let's say creating a network. Okay, so now you can see that here in the definition it is said that a network is an interconnection of two or more devices that are exchanging information. So it means that, okay, if you have two devices that are interconnected, we have basically what, a network. Okay, so if you have two devices that are interconnected, they form what we call a network. If you have more devices than two that are also interconnected, we also have a network. But now, in order to connect, if for instance I have a computer like this, let's say that this is computer A and computer B here. Okay, so in order here I have a computer B. Okay, so I have many ways that I can interconnect those two devices in order to create a network. Okay, the first way that I can use, okay, in order to create a network of two devices here, I can use for instance a cable connect. Okay, I mean this computer here has a specific port where you can connect a specific cable, and you can connect that same cable to the PCB here, which is also having the same port, and using that cable, PC A and B here will be interconnected, and you will be able to exchange resources, and at that time we have a network, and this is the most basic network that exists. Okay, so the most basic network that exists is where we have what, two devices that are interconnected. But now you can notice that this basic network that we just created is, we are having what, two computers that are interconnected through what, a wire. Okay, so now the two devices that are here, we can either connect them through a wire, okay, or we can either connect them through wireless means. Okay, because the wire is not the only thing that can help me to connect the devices together in order to form a network. We also have wireless means that we can use, that can help us for instance to connect devices in order to form or to create a network. Okay, so now another thing for instance that I can use, okay, or another technology, okay, that I can use in order to connect for instance PC A and B here, I can use for instance or wireless technology like Bluetooth for instance. Okay, or like Bluetooth for instance. So Bluetooth is a wireless technology that I can use in order to interconnect for instance two devices. For instance, when you want to share for instance a photo or a video to your friend and he's just next to you, okay, you will just activate your Bluetooth and automatically you will connect to that Bluetooth signal, and then automatically you guys will be connected and you will be able to exchange whatever you want to exchange. Okay, but at that time, the fact that the two devices or the two phones are interconnected, they form the most basic network that exists. Okay, then so far what we will be working on from now on, we'll be working a lot on wired networks. Okay, so and then later on we'll be talking about wireless network, but for now on we'll be talking a lot about wired network. Okay, so let me erase this. I hope you are following what I'm saying. Are you guys okay? My voice is clear. Are you able to see my screen and everything?
Yes.
Okay, good. So now okay, so now so now, as I said, this is the most basic network that exists, where we have what, two devices that are interconnected to what, a cable, and this cable which is here that I'm using to interconnect those two devices, those two computers here, is what we call an Ethernet cable. Okay, this is what we call an Ethernet cable. And an Ethernet cable, at the end of an Ethernet cable, we have what connectors that are there. Okay, we have connectors that are there, and the connectors that are there, okay, that are at each end of the cable is what we call we have the RG45 connector that are found at each end of the cable. So now computers, they have a specific port, okay, that help us to connect those cables, those connectors that are there, okay. And the port that is on the computers is also what we call the RZ45 port. Okay, so basically the one which is on the computer is the female one, and the one on the what on the cable is the male one, because the male one comes and you plug the male connector to the female one which is found on the computer. Okay, so now in order to create the most basic network that exists, you can make use of this Ethernet cable. Okay, this Ethernet cable, and then using just applying some, let's say, little configuration, on those devices, you'll be able to do what, to exchange those two devices will be able to exchange file without a problem. Okay, so now this is imagine that, for instance, you have a company. Okay, you are the owner of a company, you have many in your company, you have many offices, and let's say you have up to maybe 10 workers in your company, and then those 10 workers that are in different offices or department, they want to exchange files to each other. Okay, but now you want all of them, they are using computers, and you want to connect their computer so that they will be able to exchange file without problem. But now, using the cable, using this such cable, do you think that you will be able to interconnect everybody in that company so that everybody will be able to exchange file or resources? Hello guys, I want this session to be interactive, so sometime I will be asking questions for you to participate too.
I think no. Well, yes, they could. Yeah, I think yes, they could.
They could. Okay, okay. So Fran, Peter, what do you think? So let me give you a hint. For instance, right now you can see I have A and B that are interconnected to the cable. So imagine that I'm having maybe another two other devices that are there. Okay, let's say that, for instance, here I have C and D. Okay, do you think that with cables I can connect all those devices and make them to intercommunicate and exchange files with the same cable, the Ethernet cable that is there? Now, instead of thinking about 10 devices, here we just have 4 devices. So PC A, B, C, and D. And we know that it is possible for us to connect those two devices like this, A and B, using one cable. And they will be able to exchange file. But if we have more devices, don't forget that the definition of the network is saying what? It is an interconnection of two or more devices. So we saw how to interconnect two devices. But now, when we have more devices, what will happen? Yeah, Fran. Or Peter, do you want to say something? Okay, Pamela, you can go ahead.
So if computer A or B has more than one network port, I think we can connect PCD to PCB, for example. That is if PCB has two network ports.
Okay, so you are saying if PCB has two network ports, we can connect it maybe to PCD like this.
Yes.
This is what you are saying. And
Yes.
if PCD has two network ports, we can connect this to PCC like this. And the same, if
Yes.
PCC has two network ports, we can connect it to PCA like this. This is what you are saying.
Yes, please.
Okay, one more question. Are you a fresher in networking? Like, are you a professional? Do you work? Hello.
I'm a fresher, please. Yeah,
Okay.
hello, I'm a fresher.
Okay. Okay. Good. Have you ever come across this kind of computers that are having more than one network port?
Now technology, everything is possible.
Yes, I agree. That's true.
Oh, I
Everything is
don't think
possible.
so.
Okay, so
Yeah.
I will not say that it is not possible. It is rare. It is very rare to come across such devices that are having more than one network port. Okay, so I don't remember the last time that I came across this such thing, but it is very rare. I think most of the modern laptops that they are creating today, they are not having they are not having what, two network ports. Okay, only one. So today's modern computers are only having one network port. You will never find two network ports on modern computers of today's. Okay, so I hope this is clear. Okay, it was possible. I'm not saying that it is not. It is impossible. I know that there are some laptops that maybe in the past that were having, I think, at the maximum
No.
two network interface part, but those were very rare cases. Okay, so now normal laptop, I mean personal computers, are only have one network port, one RJ45 port where you can connect a single cable. So it means that this kind of setup we can never have it. We can never have it. This one we can never have it. I hope you understand what I'm saying. So the only case where you can have a computer which is having more than one network interface port, okay, is where we have a server. A server in today in modern networks of today, okay, it is only a server that can have more than one network ports. Okay, so if you, for instance, you buy a HP server or Huawei server, at the back of the server you can see that the server will have a kind of small okay, we talked about it, but it will be a kind of switch with one, two, three or four ports. Okay, so most of the time it is the server that will have more than one network port on him. Okay, but it is true that the server also is a computer device. Okay, but when it comes to personal laptop like this or end devices, okay, we will never come across with a laptop that has more than one port. I hope this is clear. But when it comes to the server, this you will see it for sure. Okay, so it's only on the server that you can have more ports, in network ports, that you can see it. But on laptops, modern laptops of today, today's modern laptop, you will never see it. You will never come across it. These such things. Okay, so now if you want, as I said, uh, Peter, I don't know if you are having an issue with your connection, or but can you mute your mic, please? Thank you. Okay, so now this is not possible. Okay, this we can never have it. Okay, so it means that, okay, based on the fact that today's computers, they are not having, they don't have more network ports, okay, where we can connect more cables. So it means that we cannot connect more devices with cables. Okay, so a cable is only made for two devices, that one device that will connect at one end and the other one will connect at the other end. Okay, but based on the fact that all those computers here, they only have one network into one RJ45 port. Okay, so there is no way for us to connect more devices. So now they came up with a solution, and that solution is to use what we call a network device. And the first network device that we'll be talking about is what we call a hub. Okay, so a hub is a network device that can help us to connect more devices. Okay, you see that, for instance, here, okay, let me just show you straight away. So okay, so using a hub, for instance, a hub is represented like this. This is the hub. Okay, this is how we represent the hub. So a hub is a network device that has more RJ45 port. So you remember that I just said that a laptop has one RJ45 port. Okay, only one. But a hub is a network device that can have up to 5, maybe 10 RJ45 ports. Okay, it will have a few number of ports, network port on it. But now, in order to connect all those devices that we have now, the PCA, PCB, PCC, and PCD, okay, what you have to do is just to take the same cable that we use to interconnect PCA and PCB and connect each devices to the hub. Okay, so now what you are going to do, you take PCA with that Ethernet cable, you connect it to what? To, okay, let's say that for instance that this hub has 4 ports. So maybe this one is port 1, this one is port 2, this one is port 3, and this one is port 4. So what you are going to do, you will connect PCA to port 1, and you will connect maybe PCB to port 2, and you will connect what? PCC to port 4, and you will connect maybe PCD to port 3 here. Okay, and now you have all the devices that are interconnected to what? To a central device. So the hub here will play the role of a central device where we interconnect all the other device that wants to communicate, and all the communication will go through that central device. How are you? Okay, are you following so far? Hello guys.
Yes.
Good. So this is what we call a hub. So in order to interconnect more devices, we will need to what? A network device, and a network device such as a hub. Okay, so now a hub is a network device that helps us to connect end devices like PCs, printers, IP phone, and any other end device that you may know. So when I'm talking about end devices, I'm talking about things, devices like PCs, printers, and IP phones. Okay, so now let me just, okay, the first network device that we'll be talking about today is what we call a hub. Okay, so now as I said, the hub is a network device that helps to connect end devices like PCs, printers, IP phones, and so on. Okay, so now this hub, okay, and this is the symbol of the hub. Okay, let me put it, okay, let me write it like this. Okay, let me say that, okay, this is the hub symbol. Okay, this is how we represent it, this is how it is represented, this is the hub. Okay, so now the hub is said to be a device which is not intelligent. So the hub is a network device which is not intelligent. Okay, it works like a cable, like a simple cable. Okay, so now okay, if for instance you have two devices interconnected like this with a cable, let's say that we have A and B here, they're interconnected to this cable which is here. So now if for instance A wants to send something to B here, he will send something over the cable, maybe a message, okay, over the cable. But now when that message will go through the cable here, the whole of the cable is to do what? Is to take that message from one end and take it to the other end. Okay, so basically what will happen, so the message will go from here and it will go through the cable till it will get to the other end of the cable. So the main goal of the cable, the main purpose of the cable here is to carry whatever information which is that, or whatever message or whatever data that will go through the cable, that will be sent from the source to the destination. Okay, so now the goal of the cable is to take something from the source and to the destination. This is how the cable works. The cable do not think. The cable do not have any intelligence. The only thing that he knows what he knows to do is to take something from the source and to the destination. This is the only way that the cable works. Okay, let me say it again. The cable does not have any intelligence. Okay, so now the hub is said to be to function. The hub function the same way like a cable. Okay, so why am I saying that? It's because if for instance A here, PCA here, okay, if PCA here wants to communicate, for instance, let's say that PCA here wants to communicate with PCB. So PCA has a message that you want to send to PCB. So it means that message that PCA wants to send to B the message is only intended to what? To B, to the computer bit Okay, so now when PCA will send that message like this, okay, and the message will make it to the will get to the hub here. When the hub will receive that message, because of the fact that the hub is not intelligent, the hub will not understand that, okay, this message that he is receiving is a message which is maybe having confidential information, or which is maybe private, and the only device that should receive it is PCB. Okay, so the hub will not be able to understand that. Okay, so what the hub is going to do, because of the fact he is a device which is not intelligent, what he's going to do, he will just take that message, regenerate it, and okay, because I mean the message that I'm talking about will come in a form of let's say an electrical signal, and that electrical signal will be regenerated and sent to all the other devices that are connected to the hub. So basically, when the message will get to the port one of the hub, what the hub is going to do is going to take that message, create copy of that message, and send it to all the devices that are interconnected. Meaning that the message will not only go to what to B, but the other devices that are here will also receive the same message. Okay, so that's why we used to say that the hub is not intelligent, because anything that you will be receiving, okay, on one port, you will be sending it to all the other ports that are active, where devices that are interconnected. So it means that if, for instance, that message was having a private information or private content, so it means that not only PCB will receive it, but the other devices also here will receive it, and they will be able to have access to the content of that message, of those messages. Okay, so you can see that here we have a security concern and a privacy concern, which is here, because the message at first was only intended to be, but now the device is not intelligent enough to understand that, okay, this message you should only send it to B, which is connected to your port 2. Okay, so we used to say that that the hub is a very big idiot. It's a very big idiot device. Okay, because it does not have any intelligence and is not able to have to understand that. Okay, and based on of this behavior, and this the normal, the default behavior of the hub. Whatever you will be receiving on one port, okay, you regenerate it and send it to what, to all the other devices that are interconnected to it. Okay, and this is how it works. So the hub, that's why I said here that the hub is a device which is not intelligent. It works like a simple cable. So now you can see that with the same thing with the cable. This is the same behavior of the cable. When the cable receives something on one end, it will take it to the other end. Okay, I can see that you raised your hands. So okay, I will start with Pamela.
Okay, so I understand the explanation for the hub, but I wanted an example like in real life situation. So I'm thinking, so if PCA, for example, and B, C, D are connected to a hub, and PCA is sending an email to PCB, I mean PCB will have its own email address. How will the message be sent to C and D?
PCB will have.
No, I wanted a real life example, how the hub works, because you said it's not intelligent, and if A wants to send something to B, it will send it to everybody.
Yes, please.
So I wanted a real life example, but what I'm thinking right now, I don't know whether it's correct.
Yeah, go ahead.
Is that, for example, if PCA is sending an email to PCB and they are all connected on a hub with C and D, how will PCC and D have it when A knows the email of B? It's a specific email, so it will go to PCB. Why should it be sent to C and D when the email, I mean, it doesn't belong to C and D?
Okay, so this is what I'm saying. Okay, when you are talking about emails, okay, when you are talking about emails, the image that will be sent from A, okay, will contain that image is a data, right? That data will be put in what you when you write your email on your laptop, it's a bunch of letters that you are writing. But now for that message to go to the cable, it will be transformed to what? Let's say it will be transformed to an electrical signal. Do you understand what I'm saying? So it means that the Ethernet cable that use what? Electrical signal. Are we okay? So now, when the cable, you will write your email here on PCA. That email, okay, will get to the network. The PC here has what we call a network interface card. That network interface card has the goal of doing what? Of transforming your data to electrical signal. So now, when the data will be transformed to an electrical signal, the data will go through the cable, and that electrical signal, which represents your data, your email, will make it to the hub here. Do you understand? And that electrical signal, okay, when the hub will receive it, it will receive that electrical signal, regenerate it, and send it to all the devices that are connected. But now, PCB, when you receive that electrical signal, that will represent what? Your email. On its network interface card, it will do the reverse process, meaning that it will convert that electrical signal to your original data, so that you will get now the email, and it will show up to your application, your email application, which is on your what? On your laptop. Okay, with all the information. But now PCCND will also receive that electrical signal. So using some means or some software, they could be able to have access to the same data. Do you understand?
Yes, please.
Okay. I hope it is clear enough.
Yes, it's clear. Thank you.
Yeah, because using a PCC here, if for instance it was a bad guy, he can have a specific software that can help him to do what? To recreate the original data that he is receiving, which is represented the electrical signal that he is receiving, and you will be able to recreate the original email that was sent from A, and you will see the content inside. Okay, so basically here, the message that will be sent from A, all the devices here will be able to receive it, and this is how it works. Yes, Peter, you want to say something? Go ahead.
Yes, please, can you hear me now?
Yeah, I can hear you.
Okay, just make a test because I have some issue with my devices, but it's okay. I'm listening to you.
Ah, okay, okay, yeah, okay. Just wanted to check. Oh, good, good.
Okay, okay. Thank you.
Okay. So this is how it works, okay? This is how the hub works. So if you want, Pamela was asking for a real life example. Okay, for instance, I don't know how we call it. You see, there is this tube. There's this PVC tube that we use to. You can put. Okay, you see your tap water. Okay, your tap water. You can connect a specific plastic tube there, and when you open your tap, water will start flowing through that tube. But when water will flow through that tube, let's say that for instance this is the tap, okay, and this for instance, let me take an example here. This the tap, okay. Let's say that for instance this is the tap, okay, and there is something like this, and water is stop flowing like this. So you can use, for instance, let's say that you have a container here, okay, this is the container, and you want to fill that container with water. So what you can do, you can use a specific tube, right? You plug, you plug the tube here. The tube will make like, maybe it will be something for instance like this, and then you take it directly to what here, directly like this, for instance to the container which is here. But now just when you open the tap here, water will start flowing through the tube here. But the purpose of the goal of this tube is to do what? Is to take the water from the tap water here and bring it to the container which is here. Okay, so we're from one end to the destination. So from the source here, when the water is entering the tube, to the destination which is the tap, where the water should fill the tank here, for instance. Okay, but now if you have any other devices, which is maybe, let's say that for instance that you have another thing. Okay, imagine that there is a wall here, and you connect another tube maybe here. So when the water will get to this to this kind of junction or interjunction here, the water will start flowing again here. It means that the other tank, the other container which is also here, will be filled by the water which is coming from the tap water here. It is basically the same thing. It's the same water which is received by all the same container, all the containers that are there. Is it clear? Okay.
Yes, please.
So the other example that I can take, as I said, because the hub, so now as I said, the hub works as a cable, like a cable. So I can replace this hub here by a cable. So now imagine that here we just have what, let's say that this is a cable. Okay, here you have cables that are interconnected here. So it's true that we are not we are not doing electrical engineering here, but you know that you can have wired, okay, wired like this and interconnect them like this. And if there is an electrical signal which is sent by a PCA here, when that electrical signal will get to that kind of junction which is here, okay, that's point which is here, what do you think that will happen to that electrical signal? It will be shared. Okay, meaning that the same electrical signal will go this way, the other some will go this way, and some will go this way. It is the same electrical signal. This is how it works with the cable, and the hub works the same way. You understand? And this is why we say that the hub is not intelligent, because it works like this without no any difference. The same electrical signal that will be sent by A, when you will get to that kind of junction here, that electrical signal will be shared and you will be sent to all the other directions that are there. Okay, and all the other devices that are there will be able to receive the same signal. Okay, and this is how the hubs work. So now, instead of like, you can just replace it now. Okay, you can just put directly what, a hub here. You put a hub here, and the hub will be working the same, like a simple cable. So now, based on your question, normally, okay, the hub, okay, is the hub when he receive he receive, for instance, the signal or the message coming from PCA. Normally, the hub should have what, a database where it can keep information, that if some information about the message or the signal that he is receiving. But unfortunately, the hub do not have any database where to keep information. So normally, you see that here we have maybe port 1, port 2, port 3, port 4, where those pieces are connected to the hub. So if, for instance, the hub, okay, let's say that, for instance, the hub was having a database, okay, and the database here, we have information about the port 1, port 2, port 2, port 3, and port 4. Okay, so this the database. Okay, it's not clear. Sorry, just a minute, let me make it clear. Okay, so basically, if this was the database of the hub, okay, just an example, let's say that normally here we have port 1, port 2, port 3, port 4. Okay, those are the port numbers. So if the hub was having a database, so when PCA is sending information, a message, and the message is received on what, on port 4 of the hub, if it was an intelligent device, it should be able to understand that, okay, I'm receiving a message coming from A, and that message was sent by a device which is called A, because that information of PCA will be found in the message sent by PCA, and the hub is receiving it on its port 4. So basically, the hub should be able to understand that, okay, I'm receiving a message coming from PCA, from a specific device which is PCA, and that PCA is connected to my port 4. So, and straight away it will take that information and put it in his database, saying that PCA is connected to my port 4, so that next time, if for instance there is another device that want to communicate with PCA, let's say for instance PCD wants to send a message to PCA, if PCD send the message like this intended to PCA, when the message will get to PC, what, to PC, to the port 2 of the hub here, the hub will look at the information contained in the message, and you will notice that, okay, the destination device here is PCA, but where is PCA connected to me? Based on the database here, the hub will be able to understand that, okay, PCA is connected to my port 4. So therefore, the message that I'm receiving for PCD, if I want to send it to PCA, I just have to send it out of my port 4. You understand? So if the hub was working this way, at that time we can say that the hub is intelligent. But unfortunately, the hub do not work like this by default. Okay, it does not have any database in order to perform this. Okay, it does not have any database where to keep those information, and this is not the way that the hub works. You understand? So the hub is not able to remember about the information contained in the message that he is receiving. That's why we say that the hub is not intelligent. Okay, so the hub let me just write it down here. I hope it is clear what I'm saying. Okay, so now let me just write it down here. Okay, let me just write it down here. So I already said it. So the hub, okay, it works like a cable. Okay, and then okay, the hub has no privacy. This one I said it, no privacy. The hub has uh, no security. Okay, no security, because the fact that all the devices can receive the message sent by one device in the hub network. So here I'm saying hub network. A hub network is a network which is created with what? Is a network which is created with the hub. Okay, and we call it a hub network. So when we have a hub network, there is no privacy, there is no security, and the hub has no database. Okay, the hub has no database where to keep information. Okay, and the hub has fewer ports. Okay, has fewer ports. Most of the time hubs has fewer ports. You will not find lots of ports on the hub. Okay, fewer ports, and it works like a cable. I already said it. Okay, so now the hub only support okay, let me just say it here. So it repeats the signal. Okay, to receive. Okay, I'll say it like this. It repeats the signal received um, received on one port to all the ports to all the remaining ports, to all the ports of the hubs. Okay, where devices are connected. Let me say it like this. Okay, so it repeats the signal received on one port to all the ports of the hub where devices are connected, where devices are connected. Okay, basically we can, in other words, we can say that it repeats the signal to all the port of the device of the hub except the one from which it received it. I'm talking about the ports. Okay, so now the hub only supports one types of communication. Okay, one type of communication. So in networking we have different types of communications. So, and then the hub only support one types of communication. So the hub support. Okay, let me say it, let me precise this, that the hub only supports one type of communication. Okay, which is half duplex communication. Half duplex communication. Okay, and half duplex communication is a type of communication in which only one device is allowed to communicate at a time. Okay, so half duplex. Okay, half duplex. Okay, let me say, in half duplex communication, only one device is allowed to communicate at a time. Okay, so meaning that if for instance I have what PC here like this, and I have PCB here. Okay, and they are connected to the cable like this. Okay, so PCA and B cannot communicate at the same time. Okay, so meaning that half duplex here communication only allow half duplex communication. Okay, what do we, okay, enough. Okay, enough duplex communication, only one device is allowed to communicate at a time. Okay, so in half duplex communication, devices cannot send and receive messages or send messages at the same time. So for instance, PCA here, if you want to communicate, okay, PCA here can send a specific message to B, but B cannot send at the same time, that like at the same time as PCA is communicating. No. Okay, PCA and B cannot communicate at the same time. This is not allowed in half duplex communication. So in half duplex communication, okay, half duplex communication, devices are not allowed to communicate at the same time. So if for instance PCA is communicating here or is sending a message, okay, PCB should wait for PCA to finish to communicate. Okay, so should wait for PCA to finish his communications, to finish to send his data, and when PCA will finish, it is only at that moment that PCA can also communicate. Okay, so they are not allowed to communicate at the same time. So when they are not allowed to communicate at the same time, and this is what we call half duplex communication. Okay, so now the hub, this is the type of communication that the hub support. So it means that if for instance we have devices that are interconnected to a hub like this, okay, we have devices that are interconnected to the hub like this. Let's say that here we have PCA, B, C, and D. Those devices, they are not allowed to communicate at the same time. So if for instance PCA is communicating, for instance, all the other devices should wait for PCA to finish his communication, for PCA to finish to communicate before they can communicate. So when PCA will finish to communicate, to send his messages, and let's say that there is nothing which is sent over the network, so now the other devices, they can try to communicate now. But if PCB is communicating, all the other devices should wait. So in half duplex communication, only one device is allowed to send messages at a time. Okay, they cannot communicate at the same time. I hope this is clear. Okay, so now what will happen if two devices that only support half duplex communicate at the same time? Okay, so let's say that we imagine that you have a one-way road. This is a one-way road, and this one-way road, it is said that let's say cars should only let's say that drive in this way. Okay, in this way, they can only drive in this way. So let's say that we have cars that are moving like this, they can only move in this way. Okay, like this. So this is a one-way road. Okay, so what do you think will happen if there is another car that is coming in the river in the other way? What do you think will happen if there is another car which is coming in the other way? What do you think will happen? Hello guys, are you there?
They will crash.
Yeah, they will crash. There will be an accident. Okay, so basically the two cars, when they will meet at a specific point, and they will crash. Okay, so this basically what will happen if there is devices that are communicating at the same time in the hub network. Because of the fact that the hub network only support half duplex communication, if there is two devices that are communicating at the same time in the hub network, the messages that they will be sending will collide. Okay, they will crash. Okay, and it will create what we call a collision. Okay, so now in a half duplex in the hub network, we can only have half duplex communication, and if devices are communicating at the same time, it will provoke or create what we call collision. And a collision is not something which is good for hub networks. Okay, collision impact hub networks in a very bad way. Okay, and I will explain that. So now okay, let me just clean here. So okay, as I was saying, so now if for instance in this example we have what, in this example you can see that PCA, okay, let's say that here let me clean here. Okay, so let's say that here PCA is communicating. Let's say that PCA sent a message at 9 o'clock a.m. okay, and also at 9 o'clock a.m. here, PCB also send what a message. That message will meet at a specific point and it will crash and it will create what we call a collision, meaning that those messages will collide. And then when those messages will collide, okay, meaning that the messages will be destroyed basically. Okay, nothing will be left when that crash or collision will occur. So now the same, this is basically what will happen in a hub network. So if you have your hub like this, devices that are connected like this, PCA is communicating and PCB is sent also communicate at the same time as PCA. What will happen? A collision will happen, and that collision could happen on the hub here. Okay, and that collision can occur on the hub here. But now when that collision will occur on the hub here, it will impact what? All the devices that are connected to the hub, meaning that all the other devices that are connected to the hub will not be able to send and receive data because of the fact that there is a collision that occurs in the hub network. Okay, so now in order to avoid this from happening, devices are only allowed to send and receive, they are not allowed to send and receive at the same time. Okay, so because if I'm sending, okay, why? Because if I'm sending something, I'm communicating over the network, so, and I'm the only one doing so, and I'm the only one doing so, and the other ones are waiting for me to finish. It means that no one of them will send a message at the time when I'm communicating, so which will prevent us from having what? From a collision to occur. Okay, so that's why in half duplex communication, devices are not allowed to do what? To communicate at the same time, in order to prevent collision from happening. Peter, your mic please. Okay, so now okay, so now another a real life example of a collision. I used to take this example where imagine that you are in a meeting. Okay, you are in a meeting with your colleagues and everything, and you want to say something. Okay, at the moment you want to open your mouth to say something, you want to say something, there's another colleague that also want to say something what at the same moment. So that will be a kind of collision, because when you open your mouth, you will say something that your colleague also said something at the same time. And what will happen most of the time? What will happen when this will happen? You guys will stop talking. Both of you, I mean the two of you will stop talking, and you will be waiting for the other one to make the first move. I mean you wait for the other one to make the first move or to talk, so that when you finish, then you can speak. Okay, so this is basically the same thing that happened in the hub network. So basically, if for instance there is a collision that occurred, okay, let's say that let me clear here. If for instance there is a collision that occurred in the hub network here, okay, if they say that PCA communicated at the same time like as PCB, and there is a collision which is impacting which occurred on the hub here, what will happen here? All the devices that are connected to the hub here will wait a specific time. It is a random time. Okay, so what will happen automatically, that when the collision will occur, that collision will create a bad signal. Okay, and that bad signal will be sent to all the other devices that are connected to the hub, meaning that bad signal will be sent by the hub to the devices that are connected here. So those devices here will be able to receive that bad signal, and they will understand that there is a collision that occurred on the hub. And what are they going to do after? They will wait. Okay, each of the devices in the hub network will wait a specific random time. Okay, and then they will wait the specific random time, and then there will be a first device that will make the first move to communicate. And when that device will be the first one communicating over the network, the other one will be waiting their turn. And this is how it works basically with the hub. Okay, so now in a hub network, okay, okay, even if okay, the devices are using the devices are communicating one at a time, okay, in order to prevent collision to occur, it happens a lot that devices maybe will communicate at the same time. But now, in order to prevent collision to occur, okay, in order to prevent collision to occur, they created what we call a kind of protocol that can help us to reduce the number of collisions that occur in the hub network. So collision occurred a lot in the hub networks, and then in order to prevent those collisions to happen, they created a specific protocol that we call the CSMA, CSMA/CD. Okay, so now the CSMA CD here is a protocol that helps, it helps, okay, it helps to reduce the number of collision that occur in a hub network. Okay, so now this CSMA here, CSMA here stands for Carrier Sensor Multiple Access, and the CD here stands for Collision Detection. Okay, and then this protocol that I'm talking about, the CSMA CD here, is a protocol which is embedded in the network interface card. I hope you know what is a network interface card. A network interface, the network interface card is that card which is having the ASG45 port on the laptop here. This is where you have the network port. Okay, the network port is embedded in what, in the network interface card. This is where you connect your cable in order to have access to the network. Okay, so now that protocol is embedded to that network interface card. Okay, so now as you can see that here we have what, the carrier sense multiple access. Okay, this is the first part of the protocol. Okay, so now how this protocol helps the devices to prevent collision to occur in the hub network. Basically, when okay, let's say that here we have, okay, let me clear here. Let me clear here. Okay, let me clear here. Let's say that here we have the hub. We have devices here. Okay, we have A, B, C, and D. Okay, so now let's say that for instance we have a device which is communicating. Let's say that over the in this hub network we have PCA which is communicating. Okay, so now the carrier sense multiple access, this first part which is here. Okay, as you can see, the carrier here in our hub network here is what is the cable here, the Ethernet cable that we are using here. This is the carrier, the one which is carrying what, the data over the network. So now we have the sense, the verb sense here. So basically the device, okay, if on PCC here, let's say that this is the network interface card, the NIC interface, the network interface card of PCC. Okay, we'll be doing what, this network interface card, this is where we implement the CSMA CD. Okay, but this protocol implemented on the network interface card of PCC will be doing what? Will be sensing on this cable if there is a communication going on this cable. Okay, because of the fact that I told you the hub is not intelligent, meaning that if PCA is communicating, that signal that the hub will receive on the port where PCA is connected, the hub will send it to all the other device which is connected here. It means that the communication of the hub, the PCA, will also go over the cable where PCC is connected. So it means that looking at this signal that will go to that cable where PCC is connected, PCC will be able to sense that, okay, there is a communication going on, because it will see that there is a signal coming from the hub on this cable where PCC is connected. So this the carrier sense part of this protocol. Okay, so PCC will be sensing the cable, will be sensing that, okay, there is a communication going on the cable, and because there is a communication going on the cable and I can sense it, I don't have the right to send, because it means that there is someone who is communicating over the network. So if there is someone communicating over the network, I cannot communicate, because here we can this hub network only support half duplex, so only one person can communicate at a time. You understand? So this is the carrier sense part. The multiple access here is the fact that this cable, this hub here works as a cable, and the hub here is a kind of medium where we have a multiple access. Multiple access based on the fact that we have many devices that are connected to what, to the hub, that are having multiple access to what, the hub. And if you can, as I said, I showed you that you can just represent that hub by what, a cable like this. Okay, so it's like we have one cable like this, and we have multiple access to that cable. See, and here we have what, A, B, C, and D. So we have a multiple access to what, to this cable. This is basically what it means, multiple access to the medium. Okay, so now the first part, as I said, is just for the device to check if there is another device which is communicating over the network, and if there is a device which is already communicating, he will not communicate, he will wait for his turn. Okay, and this is the CSMA CG. Okay, the first part of the protocol. But now, if, okay, even if they are using those protocol, okay, it may happen, it may still happen that they have what, a collision that occurred on the network. And if by any chance there is a collision that occurred on the network, okay, there's a collision that occurred in the hub network here. As I said, the collision will impact the hub, okay, and will impact the hub, okay. But now the collision will impact the hub. But now, how PCA is going to detect that there is a collision? PCA will make use of the CD part of the protocol, the collision detection. But how PCB is going to detect that there is a collision? Because PCC using that collision detection part, okay, when the collision will occur, the hub here will generate a bad signal that will be sent to all the devices that are connected, okay. And then when the PCC will receive that bad signal, using the collision detection part, you will be able to detect that there is a collision that occurred on the hub, and there is a specific process that each of the device connected to the hub will have to follow when they notice that there is a hub, there is a collision that occurred. Okay, so now this the CSMA CD protocol. This is how it works in general. But now, after that, the devices will notice that there is a collision that occurred. They will wait for what we call the back-off time. They wait for what we call the back-off time. The back-off time. So the back-off time is just a random time that each of them will choose in order to avoid each other, or to prevent each of them to send again at the same time, to communicate again at the same time. Because, for instance, if okay, let's say that there's a collision that occurred, and a bad signal have been sent from the hub to all the devices that are connected, and they have been able to detect that there is a collision, and automatically each of them will choose a random back-off time. Each of them will choose a random back-off time. Back-off meaning that, okay, they will back off, and then they will wait for a specific time before sending again a specific, or communicating again over the network. So an example that I used to take is, for instance, PCC can decide to take a back-off time, to choose a back-off time, for instance, of 20 seconds. PCD can decide to take a back-off time maybe of 50 seconds. PCB here can decide to choose a back-off time of 10 seconds. This is just an example. And PCA here can decide to take a back-off time of 5 seconds. Okay, but now each of them, they will start counting. Okay, so you can see that here, when PCB here can start counting up to what, 5 seconds. Okay, let's say that it will, after 5 seconds, PCC here will move maybe to 15 seconds, and then after 5 seconds, the same 5 seconds, PCD here will move to what, to 10 seconds, and after the 5 seconds again, PCB here will move to 5 seconds. But now PCA here after 5 seconds will move to what, to 0 seconds, meaning that its random time has exceeded. You understand? So at 0 second here, PCA will be now able to do what? Because his time, his back-off time is up. PCA, okay, reach 0 second. It means that PCA can send again a message, can communicate again over the network. But now, when you will communicate, the other one will still count down to 0 second. And they will be, when they will notice that, okay, there is a device which is communicating, they will not send anything over the network, and you will prevent them from sending another message again at the same time. I hope it is clear enough. Are you guys there? Yeah, Pamela.
Yes.
Can, yes, can you explain the timing again? How the timing, how you did the 15 seconds, 10 seconds, 5 seconds, and 0 second. Can you go over that again?
Okay. So this is just, as I said, this is just an example that I used to to make use to explain it in a very clear way. So basically, imagine that, for instance, that the back of the, as I said, the back of time is a random time that each device will choose after that they will detect that there is a collision. Okay, and each of the device will choose a random time. It is random. Okay, meaning that it will never be the same. Okay, so PCC can decide, for instance, to choose 20 seconds. PCD can decide maybe to choose 15 seconds, and PCB maybe will decide to take maybe 10 seconds, and PCA will maybe choose what, 5 seconds. But now each of them, they will maybe count down at the same moment. So meaning that the one when the PCC here will count down, maybe will count down to 19 seconds, 18, 17, 16, and you will get to 15 seconds. But at the same moment, the other devices are also counting down. So it means that when PCA was chosen what, chose what, 20 seconds, PCD choose what, 15 seconds, and PCD also will be counting down, meaning that when PCC will get to 15 seconds, PCD also will count down. It will count down maybe to 14, 13, 12, 11, and it will get to 10 seconds. So meaning 5 seconds after. You understand? And PCB also will count 5 seconds. Okay, I mean down. And it will make it to what? To 5. And PCA also will count 5 seconds down. Meaning that when PCA will count 5 seconds down, you will get to what? To 0 second. And when you get to 0 second, its time is up. Meaning that when you get to 0 second, you can communicate again. So at that time, PCA will be able to send again what? A message, because his time is up. You understand? But the other device will be still counted down. And when they will notice that, okay, there's a new communication going on over the network, they will do what? They will wait for this communication to finish before they can communicate again. And this is basically in general how it may happen. Is it clear now?
Okay, so I see that you for all of them, you are reducing them by 5. Is it because the least value is 5? That's why you're counting everybody's own to reduce by 5, so that A will take the precedence, will be the first to send, followed by the rest.
Yeah, these are the example that I just took. So I mean, I'm reducing it by 5, but it is not said that in real life the device will be reducing by 5. You understand? So this is just an example to explain how the process works, but it is not like the number of seconds that they will be reducing down is 5. Do you understand?
Okay. Okay.
Yeah, this is just an example that I have taken it just to explain basically how it works. The way they will be waiting, they will be counting down, and the first device that will count down to what its time will exceed, it will be the next one, the next one to communicate, and the other one will wait for the communication to finish before they can communicate. And this is basically how it works. Okay, but when you make the research, when you make some research, you will see they will talk about the back of time, and they will say that the back of time is random. So meaning that each device will choose a random time, and each device will be waiting that random time. You understand? So it means that if PCA waits, choose what, 1 minute, so PCA will be waiting 1 minute before communicating again. You understand? So if PCD waits, decided to choose what, 10 seconds, he wait after the 10, he will only communicate after the 10 seconds that he have chosen. But now the time is random. They will choose it randomly, meaning that it will not be the same for all the devices that are connected to the hub, which makes it that there will be one device that will exceed its time first, and it will be the first one communicating, and the other one will be waiting. I hope now it is clear. Okay.
Yes, please.
Okay, so now let us okay, so I think okay, so concerning the hub, I think we talked about everything, so we can move on. Okay, so now you can see that with the hub we have a lot of issues. The hub has a lot of issues, and in today's modern networks we don't use hubs anymore. Okay, I'm not sure that you come across hubs in today's modern networks. Okay, so someone one day I was discussing with a colleague. He said that okay, he came across what one hub, but that hub was there. They would, I mean, years back to since they installed that hub, they never removed it, but it was very old hub. But in today's modern hub networks, you will never come across what hubs. We don't use it anymore in today's modern networks.